Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. This week we're answering a question sent in from listener Tony. He asks,
I heard that water that has previously been boiled freezes much faster than water which is not. If true, how is that possible? Kind regards from Papua New Guinea, Tony.
Good question, Tony. In 1963, 13-year-old Tanzanian Erasto Mpemba was making ice cream at school. Due to time constraints, he decided not to let the mixture cool down and instead put it straight in the freezer, and found to his surprise that the mixture had frozen faster than everyone else's. So was born the Mpemba effect, the theory that hot water freezes faster than cool water. But what does the science say? I asked an expert in fluid mechanics at Imperial College, Henry Burridge. Fortunately for us, Henry spent a lot of time studying this theory.
Well, we started out really trying to prove why this would happen in the hope that it really did happen, and looked very much at the cooling process. So the idea being that if water cooled in such a way that it gained a lot of momentum, the motion in the fluids was important. When water at different densities drives motion, this could potentially cause warmer water to cool at a greater rate than colder water. We did definitely observe that, but we never observed that greater rate of cooling carried through into lower temperature states. So if you like, the hotter samples that we cooled, they could never overtake the cooling process of the colder samples.
So no, the purely scientific conclusion states that if you change nothing in either experiment other than water temperature, hot water cannot cool or freeze quicker than cold water. So why has it been observed so many times? Well, the answer might be to do with the conditions that the water is frozen in.
We did some work where we either sandpapered the inside of a beaker or the outside of the beaker so that heat transfer properties were the same in both cases. But in one case, the water was in a relatively smooth container, and in the other case, there was lots of these minute imperfections.
These imperfections create nucleation sites. It sounds complex, but all you need to know is that a rough edge or a dust molecule or something similar makes water molecules align more often, and so makes it favourable for the molecules to shift phases, which is to say turn from water to ice.
By biasing whether the water was in a container with a smooth inside or a container with a roughened inside, then we were able to get hot water to freeze in less time than cold water.
So a rough container with hot water will freeze faster than a smooth container with cold water. It should be stated, however, that cool water in a rough container will still freeze faster than hot water in a rough container. So perhaps then Mr. Mpemba had a rougher ice tray than everyone else.
I think it comes down to this lovely nuance that it sounds like a really simple question, but you have to very precisely define what you mean. And if you mean that all aspects will be identical, except for the initial temperature from which you cool the water, then the answer is no. It cannot be done. But if you allow really subtle changes, like your hot water samples to be cooled in a container which is only changed by sandpapering the inside of it, then you can get your hot water samples to freeze in less time than your cold water samples.
Thank you very much to Tony for the question and Henry Burridge for the answer. Next time, we're answering this question from listener Cecilio.
I want to know, how does the sun's impact change on tattooed skin? Could tattoos protect us from getting burned? Thank you.
And if you have a question of your own, please do send it in via our website, nakedscientists.com, or email us at chris@nakedscientists.com.
Question of the Week is part of the Naked Scientists podcast and supported by the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.